సో ఇప్పుడు మనం ఏం చూడబోతున్నాం అంటే టైం పీరియడ్ ఫార్ములా క్యాలిక్యులేషన్ చూడబోతున్నాం, డెరివేషన్. ఇది ఎలా చూస్తాం, ఎనర్జీ మెథడ్లో చూస్తున్నాం. దిస్ స్ప్రింగ్ ఈజ్ గోయింగ్ టు హ్యావ్ energy, right? When it is some extended state, in second diagram, when it is extended, this spring can have some energy, stored energy it can have, right? So that is the spring potential energy, spring potential energy. And when this is moving with some velocity, it is also some energy, that is a kinetic energy of mass. So but mechanical energy, right, we can say mechanical energy of the system is constant. Mechanical energy is constant. What it means, so total energy of the system is constant. What are the total system here terms involved? You can say that potential energy plus kinetic energy. So what is the potential energy of that spring? Half k x square. What is the kinetic energy of this mass? Half mv square is equals to what? Constant. Now if you differentiate with respect to time, differentiate with respect to time. So when you do that, what will happen? Do it, differentiate on both sides of that above equation, this one equation. Now differentiate with respect to time. D by dt of half kx square, right, plus d by dt of half mv square equals to d by dt of constant, right? You're going to get it. So half into k is a constant values, na, take it out. Half k into d by dt of x square plus here half m you can take out common, d by dt of v square is there, that equals d by dt of constant 0. d by dt of constant 0. Now here we have to understand one more thing. What is that? Suppose dy by dx means you are differentiating y with respect to x, right? అలా రాస్తున్నప్పుడు మళ్ళీ ఏం చేస్తామంటే y is a function of x అని రాస్తాం. సపోజ్ y ఈక్వల్స్ టు x స్క్వేర్ ఉందనుకోండి, d by dx of x square. Directly we have formula d by dx of x to the power of n, you can solve it. But if you have the y in y terms only, then how you do that? That is different, right? అలా చేసినప్పుడు ఇక్కడ అలాంటి సిచ్యువేషన్ జరుగుతుంది. యు ఆర్ డిఫరెన్షియేటింగ్ ఎక్స్ విత్ రెస్పెక్ట్ టు టైమ్, మీన్స్ ఎక్స్ ఈజ్ డిఫరెంట్, టీ ఈజ్ డిఫరెంట్, దోస్ ఆర్ నాట్ సేమ్ టర్మ్స్. అప్పుడు ఏం చేస్తున్నామో ఆ ఫార్ములా మామూలుగా మనం ఏం చేస్తామో అదే చేస్తున్నా. డి బై డిఎక్స్ ఆఫ్ ఎక్స్ టు ది పవర్ ఆఫ్ ఎన్ ఈక్వల్స్ ఎన్ ఇంటూ ఎక్స్ టు ది పవర్ ఆఫ్ ఎన్ మైనస్ 1 చేసిన ఇంటూ మళ్ళీ ఏ రెస్పెక్ట్తో నువ్వు డిఫరెన్షియేట్ చేస్తున్నావో డి బై డిటి ఆఫ్ విచ్ టర్మ్ అనేది మళ్ళీ రాస్తాం. దట్ ఈస్ ద థింగ్ వాట్ ఈస్ హియర్ ఇన్వాల్వ్. సో హాఫ్ కే ఇంటూ డి బై డిటి ఆఫ్ ఎక్స్ స్క్వేర్. ఎక్స్ స్క్వేర్ మీన్స్ 2x ఇంటూ again what you have to show with respect to what you differentiate, that you have to show dx by dt plus half into m into what is that 2v, you are going to write it, and after that what, with respect to what you are differentiating, you have to show it dv by dt equals to 0. Now what you can, 2 gets cancelled, kx, dx by dt, what you have, dx by dt, rate of change of displacement, you are going to get, right, velocity. And what is a dv by dt, rate of change of velocity is equals to acceleration. So that terms you can write here, right? Here common is 2 you can cancel kx into what you can write, dx by dt v plus 2 gets cancelled, m into v into what you can write, dv by dt a equals to 0. Right. So what is the meaning of a? Here we have common thing again v, that v you can take out common, you can send that side, v into kx plus m into a equals to 0, again send that side, ma equals to minus kx, right, minus kx, a equals to minus k into x, and if you compare that equation, a equals to minus omega square x, omega square x, these two equations if you compare, what is the omega? Omega equals to, or simply you can write it, right, it is I think m we left m, okay, m we have to send that side, right, m k by m. Right, now a equals now compare these two three equations, so these 2 and 3 equations, omega square equals to k by m. So this is very important relation where we are going to use it. And next that again how we can write omega equals to square root of k by m. So but we need time period, right, we need time period, we need time period, t equals to 2 pi by omega, that means 2 pi by square root of k by m, that again if you simplify it, 2 pi into square root of m by k, this is again what we got, so t equals to 2 pi into square root of m by k, this is what we already derived in the force method, and the same relations you can understand, directly proportional or inversely proportional, right, what is the meaning of directly proportional to the square of that physical quantity, like you can pay much attention to understand this, okay, right, thank you, this is the energy method, and we got time period. So frequency, if you want frequency, what you can do, we know that frequency is reciprocal of time period, so again you can write it, right, if you want frequency, so that means 1 by 2 pi square root of m by k, that means 1 by 2 pi into square root of k by m. The frequency, what will happen to the frequency, will the spring make more oscillations or less oscillations, that depends on the frequency, right, now you can understand it, if spring constant value is more, okay, what about frequency, and mass is more or less, so how it is going to do it, you can think of it, right, thank you.